Okay, everybody, welcome to the bench. Today we have a new project. It's kind of an old project for me, but a new project for you guys. And what we have here is a Hewlett Packard Model 606A signal generator. And this thing was made 1959, I think. And one of the problems that I'm having with it is first off, let's describe this thing. It's a RF signal generator, first off, and basically the output goes, this is your output ranges, from 50 kilocycles up to 65 megacycles, or 65 megahertz, and it has 1, 2, 3, 4, 5, 6 bands. So the band first, the first band, the lowest band, is 50 kilocycles, 170 kilocycles. Second band is 165 kilocycles to 560 kilocycles. The third band is 530 to 1800 kilocycles. Then the next one is 1.76 to 6 megacycles, or megahertz in today's vernacular. The next one is 5.8 megacycles to 19.2 megacycles, or megahertz again. And the final, the top band, is 19 megahertz to 65 megahertz. And you adjust that by the range switch here. As you see, the little red pointer, when you switch it up, follows the band. Then you have your frequency, big knob, tunes your frequency. The little knob is vernier. You can do coarse, fine, basically what that means. Let's see, you got two lines, you got a RFB plus fuse here, which goes inside the tank circuit in the cage. The line fuse, on off of course, indicator. This thing does, this also is a AM mod. It'll do 400 hertz or 1000 hertz internal, or you can apply an external mod through this jack right here, and it could be AC coupled or DC coupled, and it works very well. Percent of modulation meter, which is very cool. And then here's your output level. This thing is capable of generating plus 20 dBm, which is 3 volts RF. It has a crystal calibrator on it right here. Plug your headphones into there. It's got 1 megacycles and 100 kilohertz. So all you do is, like, if you come over here to 530 to 1800, turn your crystal calibrator on to either 100 kilohertz or 1 megahertz. Plug your phones in there, listen, and tune this till you get a 0 beat right here, and then you adjust your calibrator to match where that 1 megahertz is right here. When you're done, that band that you're working on is done. Turn your calibrator off, RF output. Now, this thing works really good. It took a lot of work to get it even working. I had a couple of bad electrolytics in it. It was very nasty. I had to clean it up and all this stuff. But one of the problems that I'm having is right here. The RF level. You see how it varies? It's very odd. See how it's working? I worked on this before and thought I had it fixed, and it turned out to be there's a micro switch in here that when you change the bands, it disables the oscillator temporarily until it switches over the other band. I think that's to protect all the switching circuits in here. This is the only problem with this thing, and I'm going to get back into this thing, and we're going to fix this thing once and for all. So right now the third band is 530 to 1800, and it's doing it. Let's switch it down. See? It's doing it on the 165 to 560 kilocycles. It's also doing it on the 50 to 170. See, that is the same exact symptoms that I had before, and I'm kind of wondering if that same thing, and when I get into this, I'll show you kind of what's going on. See, as I mess with this knob, I have a feeling I know what this is, and I didn't apparently repair it right. Anyway, I'm going to drop it. I'm going to take the camera loose. We're going to take this thing apart, and I'm going to get into the circuitry that I need to get into, and kind of get the schematic out, kind of show you what I've got going on with this thing and what I think the problem is, and then we're going to figure out a way to test this. So I will bring you back. Okay, this is the back of the unit. The line cord is a fairly heavy-duty line cord. It has a 3-prong outlet. You ground, you hot, and you neutral. Let's see, this one here happens to be a U.S. Navy. In other words, it was issued to the U.S. Navy. So somewhere on here is a, well, yeah, right here, MATC. I have no idea what that means. If anybody does, just let me know in the comments. Anyway, to get access to it, you have to take these two screws off here. This one, this one, this one, and this one. Pull this back cover off. And when you do, the next thing that you do is there's two, and I'll show you that in a minute, but there's two more screws that you have to loosen and pull this thing out of the chassis. And so let me get the back off, get this undone, and then I'll show you how to do the rest. Be right back. Okay, now that I have the back taken loose, now I've leaned it over, propping it on my stomach just to have a third hand. Now you have, this is where the line cord comes in, right here. Goes into this box here. This is actually a RFI filter, radio frequency interference. It keeps the signal that you're generating inside this unit from reaching the outside world and interfering possibly with your measurements. And also it keeps any kind of line interference from the outside world getting into your equipment. So next thing we have to do is you have to take it off this clip right here and just unplug it. Now that that's unplugged, we can remove this out of the way, and we'll just put it over here top of that stuff right now. Now you got to look inside the inside. Here's the power supply right here. Here's the RF cage right here, which is what we'll have to get into, which is not easy. But I'm going to try not to do that just yet, because I think what I need to check can be done without opening this up. So anyway, now I got to open this up, so I'll bring you right back. Okay, now that I have it on its back, this is the next step. You lay it on its back after you take the rear cover off. Now if you look right closely, there's a screw right here, the corresponding screw on the other side. You have to loosen these screws up, and watch what happens as I loosen them up. You ain't got to take them out, you just got to loosen them for 4 or 5 turns. And I'll show you how this works. Should be good. I'm going to put you in the tripod a minute. So let me get it set up. I'm going to put you in a tripod, because I need both hands for this next phase. Alright, here we go. Now if I did this right, all I should have to do, pick up the shell like that. Now that I got it off there, I'll show you how this works. Notice that this actually is a rack mount, or can be rack mounted, which is very cool. Hewlett Packard made some fantastic stuff back in the day, and this thing is really built like a tank. Anyway, here's these two screws right here. This is one of them. Notice the pointed head, and then the corresponding one on this side. So what that does is you'll notice right there, if you can see it, got this little lip here. So what happens is that clip hangs onto this part of the front of the instrument. So set it in there, and then those two screws screw in. If you'll notice right there, those two screws, when you tighten them up, pushes into there. And what that does is it secures this to the case. That's really all there is to it. So with that said, let me clear up the bench, get this thing ready for setup, get the schematics and all that, and I'll bring you back. Okay, about the time I hit the record button on the camera, the air conditioner came on. Anyway, what we think I have going on is this section right here. And what we have here, if you look real careful, is that you see it says cam. This is on the range switch, okay? So this is a cam right here that's on, and I'll show you that in a minute. But there's a micro switch, 3-pole micro switch right there. And 300 volts comes in. Here you have a control called maximum carrier set. So the 300 volts goes this right here. And what this does is, in normal operation, this sets the total amount of RF out that this thing has. And needless to say, what happens is this cam and this switch are not perfectly aligned, which means when it's sitting there, this is the problem I found before, when it's just sitting there, this contact right here takes this 300 volts to the max carrier set and applies it to this cathode follower differential amp setup, and this is where the carrier is actually set up. But anyway, this cam and this switch are not quite lined up properly, I don't think, which means we're losing the voltage here, or very intermittently losing the voltage here. So what I'm going to do is I'm going to find this test point right here, and I'm going to put my scope on it, and I'm going to see if, while this thing is acting up, what my voltages are doing here, and that will tell me if it's this cam or not. So that's what I'm going to set up next, and I'll bring you back when I get ready. Okay, I think I got everything set up. Let's review this circuit one more time. As you change the range switch, the cam basically pushes switch 7 from the normally closed position to the normally open position. So it takes this 300 volts, routes it through R64 30K to ground. So as it comes to rest, when you get on the selected band, as it comes to rest, then the S7 closes back to its normal closed position, and then routes this 300 volts adjusted voltage through here, through these two resistors, out to where it needs to go. So my scope is supposed to be on this test point right here to ground, set on DC voltage. And let me show you the cam if we can see it. The cam is actually right here. This is the cam switch right here. You see, if you can see it, there's the slots that the cam, the switch goes on, and I don't know, you can almost see it in there. Let's see, there it is. This black switch, right here is the switch in question, and I'm on this test point right here, which should be the output that I'm looking for. So I have my scope set on ×10. I'm expecting somewhere around 130 volts, so I'm on the 5-volt scale. So that's 5, 10, well, I'm sorry, 50, 100, 150. So anyway, I guess I can drop this down to 2 volts. So that'd be 2, 4, 6, 8, 10, 12. So we'll see. I've got this scope on DC coupling, channel 1. So let's see what happens. I've got it plugged into my isolated power supply. Alright. Power up. I don't know if you can see that or not, but let's see what's going on. And you know what, the output is stable. So let's change the range. That's about right. But if you can see what the scope is showing, I'm going to change the band. Watch the code. You should see this voltage drop. Not very well. Yeah, see it drop for just a minute. There we go. Well, as stable as can be. Figures. I'm convinced that's what it is. I'm convinced it's mechanical in nature. So let me mess around with it a minute, see if I can recreate the issue, and we'll look back at the scope again. Okay, on that last segment, I had my scope on the wrong spot. I wonder why I couldn't get a very good trace. I had it on the wrong side. Where is my pointer? Coming back over to the circuit. I had my scope on the wrong side. I actually had it, I think I had it on this side right here. Now I've got it on this side. Now it functions correctly as far as the readings on the scope. So let's try this again. Set you on top of the instrument. Stable. We'll change the band. Now we can get indication. Now as I change the band, you see the voltage drop to 0. That's what we're supposed to have. That's what it should look like normally. So let's bring it back down. Stupid thing will act up. We'd have something going on here. But it's laying on its side and it's out of the case, which may be affecting how this thing operates. If that cam's not quite adjusted right, I can see that happening. So I guess what I'm going to do is I'm going to lay this thing back in its normal position, flex it around a little bit. I still think that cam's out of adjustment. So I'll bring you back for anything worth bringing you back for. Well, I'm not sure that I'm barking up the right tree. For the simple matter is, I can go in here with my test probe, and I don't know, let me see if I can get it. Right there is the arm of the switch. If I push in the arm, I don't know if you can hear it or not, there is plenty of travel. It ain't like it was last time where the switch was just not barely making, it was so much pressure on that arm that it was kind of in between. There's plenty of play in that, which tells me it's lined up. So I don't think I'm on the right track. The switch appears to be switching normally. It doesn't seem to be intermittent contacts on it. However, I do have fluctuation still, just barely, not like it was, but just a little bit of fluctuation in there, which this thing should be steady because it is a regulated power supply. And this is part of the regulated power supply right here, and it appears to be steady. I don't see any fluctuations on it. I'm going to move over to AC. I'm going to increase. I mean, it's nothing that I can see. I'm going to slow the sweep rate down a little bit. There's something there at fast rise time. So go back up to 5 volts, go back to DC. Alright, I'm going to turn it on. Don't know. What I'm going to do is I'm going to set the only thing that's changed is on this is pulling the cover off and laying it on its side. Let's move this down. Let's move the range switch down. Watch as I change the range switch. See it drop, the carrier drop off until it's I think that I guess the range switch cam on it, I think that in that micro switch is probably alright. So I don't know quite where to go with this. Let's look at the schematic again. What can we do in the meantime? Looking back at the schematic, let's go back to this set point right here, this maximum carrier set R60, which is a variable 10K. It's possible this pot might be dirty. So what I've done, set the zero reference right here for 0 using the attenuator fine adjust. So I've got it set for 0, and your maximum carrier set is this control right here. This is it right there. So what I'm going to do, I'm just going to bump that control with my screwdriver. You're not supposed to do this, but I know where I'm starting from, so I think I can safely get back. I just want to see how it responds when I just play with the control, because sometimes the control could be bad, but I think this is a wire around control. But let's try. Control does not seem to be bad at all. It's smooth all through the settings. So don't think that's the problem either. I don't know. Honestly thought this was going to be cut and dry. So don't know. Me mess around with it, and if I can get it to act up like it was a little while ago, I'll bring you back. Okay. Alternate plan W. In other words, whatever. Let's see what we got here. Circuits of this signal generator. Let's see if we can figure it out here. This is your audio oscillator section right here. Consist of a 12 AT7. Let's see, and then a 12 AT, and let's see, that's another 12 AT7. This is the modulation monitor, which drives the meter. Let's see, then your mod input comes through here. Your output of the modulator applied to a 1 microfarad capacitor over to the I believe this is the carrier set section right here. So here comes our voltage right here, which is direct coupled straight to V8, which should be another, let's see, a 6AW8 differential amplifier. And basically this is a return loop right here. Comes from the sample of the output section, comes through here, comes over here to the control grid of this differential amplifier. Well, with all that differentialing going on, I'll say, comes back over here and affects the screen grid. So this basically is what actually sets, I don't remember how this works. Yeah, this basically sets the RF output. That's how it levels. Let's see, come over here. Here's the RF oscillator section right here. Here is a tune circuit right here, which is part of the carousel or turret, should I say. There's two turrets in here, one for the oscillator section, and I'll show you that shortly, and then another one for the output section. Anyway, what we want to do is we want to monitor the output right here feeding the RF amplifier and see if it's stable. And if it's stable, then the output is still varying, then that tells me the problem's from here to here. And then if it is going crazy here, then we need to find out what's going on down in this section here. So anyway, that's not an easy thing to do, but I'll bring you back when I get it set up. Bye-bye. Okay. This is the RF cage. This is where the oscillator section is. To access it, you got to be real patient. There are 5, 10, 11, 12, 13, 14, 18 screws just for this section. Then you got this brace here and another one here that you have to take off, and you'll notice this really long Allen wrench right here. And you'll notice these two screws. Now this has to be used to reach down here to some Allen head screws. So anyway, you have to lay this thing on its front, take all this stuff off, then you can get into this cage. The nice thing about this, it's not effective with the cage on or off, so it doesn't really affect measurements. So I'm going to take the cage off, which if y'all ever had decided to work on one of these, I don't think you need a detailed video of that, which will bore you and it'll bore me and make my videos way longer. And I'm trying to make my videos less long. Anyway, bring you back when I get it open. Okay, we are in the belly of the beast, if you will. You now have access to it. And this is the RF cage right here. One thing I love about this old HP stuff is this stuff is just built so easy to service. Mostly. Two big old tuning gangs here. One is for the oscillator section, which I think is this side, and this is the amplifier section. Let's see. Here is a turret. This is that turret. It's got multiple tune circuits on it, so as you change a range switch, it actually turns both of these turrets. You see that it's geared. Both of these operate in unison. Unison? Anyway, so there's some contacts in here. Don't know if you can see them very well. Yeah, it's hard to see. But if you see here, these contacts right here, that is, each tune circuit has some fingers. And those fingers, let's see if I can find it. Corresponding connections right here that attach to it. And this goes to the, I believe this is the the amplifier section, and this is the oscillator section, or vice versa. I don't remember. But it's really cool how it's designed. All your tubes and switches are right here. I did, on the last time I serviced this, these capacitors were them old, they look like those silver mica capacitors, you know, the domino capacitors, and every one of them was leaking. So I changed every one of them out with brand new modern equivalents. These are still mica capacitors. These things are about $5 to $8 a piece, depending on your value. So all that's been corrected. So I guess now I'm going to play around with it a little bit more. Oh, this electrolytic, when I first got this thing, this electrolytic right here, which is a 1010 at 450, was completely shorted, which blew this fuse right here, the RFB plus 150 milliamp fuse. So I replaced those just with these little radio lead capacitors. No problem there. So I guess now that I'm going to give you kind of a brief show of this thing, I'm going to get to where I can get to everything test wise and adjustment wise, and power it back up, and see if I can get it to act up and find some test points to measure. So I'll bring you back. Okay, well, got it powered back up, and it seems to be a little bit on the wanky side. It wanted to be a little bit belligerent till I turned the camera on. So I'm going to get back on that voltage rail that I was on a few minutes ago, because that little bit of fluctuation earlier might have been normal. So I'm going to probe. I'm probing with the oscilloscope again on that power feed to the carrier level drive. That's what we're going to call it, carrier level drive. So just in case that switch is wonky. One other problem that I have, if you'll notice, is this meter hangs up. See, I've turned it all the way down. So that's another issue that I've got to deal with. So, what do we do? See, I've set it. It's already changed. Did you see that? So, I'm wonky. So let me find out what's going on here. Let me get a test point where I can measure. I still want to I need a reference. You know, when you have a issue like this, especially in a semi-closed loop like this is, you need a reference. So my reference is going to be the output of the oscillator, which feeds the input of the RF amp. So I'm going to find V3 and V4, and I'm going to get on the grids and look at the signal level coming out of that. And I'm going to see if that is constant in relation to what the output's doing. So let me do that and I'll bring you back. Okay. What we're looking at is right here. I'm looking at the grids of the RF amplifiers, which is the signal from the RF oscillator. So I'm using my trace 1 and 2 of my dual trace to look at each grid, because if one goes wonky but the other one don't, that will cause the same issue. So right now, extremely stable. I don't see any issues with voltage levels. So see, I can turn it all the way down, all the way up. You see the RF level is not get affected. However, you see that the output is fluctuating. Yeah. As far as I can tell, the input isn't. You notice how that's out of phase with each other? Push-pull. Coming out of a tuned circuit is basically a transformer. Center tap transformer. So anyway, now that we had a reference, let's find out where it's fluctuating. So well, really could use another scope. And the output is already changed. Something's affecting the output. What could it be? I'm going to dig around a little bit. I don't want to bore you with a lot of useless mumbling, blumbling. So when I come up with something that might be of interest, I'll bring you back. Okay. You know it's an intense little project when you bring out second scope. This is an old Kenwood 40 megahertz CS4035. It's a fairly old scope. I think we actually found it at a garage sale for like $5. And it's not too bad. It's stable. It did have its problems. It had some electrolytics on the circuit board that wasn't quite right. I had to replace it. Still has some circuit board damage. But it's a good backup scope to do what I want to do. I wanted that just to keep a reference of the hang on. Okay, sorry about the interruption. I figured out where we were at. We got the secondary scope looking at the input of the amplifier section. This scope here, my Textronics 2246 channel 1, is going to be the one looking for stuff. But I think, let's get over here to the schematic. Going back to the amplifier circuit here. This is the input right here, as you should know. What I think I might do, you have B plus comes in, the RF B plus comes in through here, through that 0.15 amp fuse that we showed you on the front panel, through a feed through capacitor, through 2.1s, and a choke coil. This is actually a pi section filter, apparently it's for RF. And then here's those two 10 microfarads that I showed you a while ago that I told you was shorted. Then another filter here and another capacitor. Anyway, this comes down and comes over here to the screen grid, I believe, of the 6CL6. Comes down, as you can see, comes all the way down to this point right here. So this should be 295 volts. So what I want to look at is I want to look at pin 9 of V8. I want to monitor that voltage. So I'm going to monitor that voltage with my VTVM. and I'm probably going to put a scope on this line right here on pin 7. So I'm going to monitor pin 9 with a VTVM DC volts, and I'm going to monitor pin 7 of the differential amplifier with an oscilloscope, and that'll give me a reference to go. So I'll bring it back. Okay, let's have a look at things. Again, coming back over here, I'm looking at V8 of the differential amplifier. Pin 9 should be about 76 volts. And I'm looking at the DC voltage with the VTVM right there. And then on pin 7, right there, I'm looking at AC, which is saying here 2 volts, and it says there's a sine wave, and it should be about 3.1 volts. So hang on just a second here. So first off is the VTVM. Actually a little bit more than 78 volts. If it's fluctuating, it's not picking it up, which means I may have to use another channel on my oscilloscope. But let's look at the scope. This is pin 7, and I've got my scope set on channel 1 DC, and as you can see, there is fluctuations there. But as you can see, from best we can tell, the RF input stage is stable. So we got to figure out where that's unstableness, that shifting is coming from. So let me think about this a little bit more, and I'll bring you back. Well, desperate times calls for desperate measures. Just playing around a little bit. Look at that. What I found, watch the oscilloscope. Tapping on that tube right there. Going nuts when I tap on it. If I tap this tube, it's fine. If I tap that tube, it's fine. If I tap that tube, it goes nuts. That tube, if I remember right, is V8, which, guess what? Differential amp, which is a 6AW8. Is it possible I have a bad tube? Because look what happens to my output level has dropped. That is the only thing I found. So I'm going to see if I have a 6AW8 in my stash somewhere. We'll change it and let's see what happens. Okay, I actually have 2 6AW8s. So let's see what happens. That tube is probably going to be hotter than the hinges to the gates of hell. I don't believe it's a tube socket. Tube is mighty black. Look how black that tube is. Yeah, it's really black. So I got one here that's in a GE box. But I got another one here that's in an RCA box. What do you think? RCA? Now if this works, I will get online and order a actual Hewlett Packard 6AW8, so that way all the tubes will match. I don't know how good this tube is. Every one of them I've tested, so you know how testing goes. Testing doesn't really test real world. Alright, here we go. Tube is changed. Let's see what happens. Warming up. My output voltage actually, yep, it's going back up. There we go. He's waking up. That voltage level has increased. It's made some difference. Let's see if it's still microphonic. It is not. And my output now you gotta see this. It didn't change this voltage any, but that's probably not where I need to be measuring. But this actually way up. And my meter, my output meter, steady as a rock. And it is not. Remember, I could tap on this tube a few minutes ago and that display would go nuts. I think that took care of it. Amazing. The 6AW8 right here. Now that all that's changed, I'm probably going to have to recalibrate this whole thing. Yay. So let me get my spectrum analyzer out and we'll set it up and let's just see how close it still is. Alrighty. Really got the big guns now. We have two oscilloscopes. The Kenwood 40 megahertz CS4035 and monitoring the oscillator section of the signal generator. Then I have the Tektronix 2246 just doing various things. Right now it's stage is looking at, we don't really care about. And then the big guns, we got my trusty dusty old Hewlett Packard 8568B spectrum analyzer. It goes from 100 kilohertz to 1.5 gigahertz. Anyway, right now I'm looking at the calibration coming in. The calibrator output is 20 megahertz at minus 10 dBm. Center frequency 10 megahertz, and I'm one division down, and it's 10 dB per division, so that is accurate. So let's set the center frequency 1 megahertz. Come back over here to the output. And we're about a little more than 20 dB. So let's put on the peak. Let's see, normal at minus 21.5 dBm at 1 megahertz. See what we got. Minus 20, almost at the zero. And at the zero, that should be minus 20. Look at there, right on the button. I'm good with that. I think this thing is fixed. So I'm going to the long arduous labor of putting this thing back together and putting it back up there, and let's see how it behaves. So wow, I wasn't expecting a tube. Actually, in the back of my mind I was, but I didn't know what else it could be. The last time I worked on this, it was that switch. It was that what's the switch over here where it went. That was a problem, but that wasn't the only problem, because after I fixed that switch I still had that variation, and I'll be dang, I started tapping around, just, you know, kind of a Hail Mary type thing, you know. Sometimes, you know, what else do you do, you know, frustration. I mean, I sat here for a long time trying to figure out what the hell it could be, and but finally I just did the old television repairman trip, which I am a retired television repairman, believe it or not. Started tapping on stuff, and I started tapping on one. First thing I did is start moving tubes with my finger, trying not to shock myself. Nothing. These sockets on these things are tight and they're clean. It wasn't that, so I got the old Chinese stick here, chopstick, one of my favorite little pointing tools. Does everything. Keeps me from getting shocked. I started tapping on stuff, and boy, when I hit that tube right there, just tapped it lightly, the oscilloscope went crazy, and I looked up front, and it had completely changed the output level. This thing is rock solid. I hadn't seen that since I first powered this and got this thing working. So let's, I'm going to shut you down for a few minutes, and I'm going to put this thing all back together and put it back in the case and go from there. So I'll bring you back. Okay, I've got everything together but the back case, and I'm going to do another little measurement here. I really just want to look at the mod and a few ways I can do it. The output level, I believe, is still going to be okay as far as using the spectrum analyzer, so I'm not going to worry about the output level. I trust it. This thing was dead on since the day I. What I'm going to do is I'm going to, let's see, I want let's see, amplitude minus 20 dBm, and I'm going to give it AM 30%. What I'm going to do is I'm going to look at the mod on this thing, and this, to be accurate, it has to be terminated into 50 ohms. So at the end of this cable feeding the oscilloscope, I have a 50 ohm load terminator, excuse me. So what I'm going to do is I can do the math and all that, but just really hate it. Let's see, am I not? Had to sync it. Let's see. Let me get it to lock in. Go here, position. So we're almost full scale right here. So at 30% modulation, at minus 20 dBm amplitude with 30% modulation at 1 megahertz with an amplitude of minus 20 dBm into a 50 ohm load, this is what we have. This is 30% mod. And this is my Hewlett Packard 8657A signal generator, which is 0.1 or 100 megahertz, I'm sorry, 100 kilohertz to 1040 megahertz or 1.04 gig. Anyway, this is what it looks like on a oscilloscope right there. So we're going to come over here, same thing, we're going to set the output minus 20, adjust your vernier for 0. When this is at 0, this will be minus 20. If it was at minus 10, this will be minus 10. You just subtract whatever this is from this, or add if it's above. Anyway, we're going to do 400 hertz deviation, and we're going to set this for 30%. And I'm going to see if it matches this. So I'm going to take it from loose from here. Oh, we got to set this for 1 megahertz. It should be that. So here goes nothing. A little bit off frequency. There you go. Signal level's a little off. That's pretty close. That is close enough. So with that, the output level is stable, the mod is right on, frequency is right on. This thing is dead nuts accurate. When you use the calibrator, this thing is super accurate. I love this machine. It's big as a Volkswagen, but I love this machine, and hopefully this is the last trouble I'll have out of it. So anyway, I'm going to button it up, put it back up, and hopefully be done with this project. I do appreciate you guys riding along, and I hope you enjoyed it. And you know, we repaired this thing together. This thing is I really hated the boat anchor because it's really a cool piece of test equipment. It doesn't go up. One thing that I don't like about it, it doesn't go up into the FM band, which would have been really cool. But it's fine. It's still good for everything else. It's just a really neat machine. The only other caveat I don't like about it, it's just so huge, but it's super accurate, but like a tank. This thing should last me a long time because it's going to be in a cool, controlled environment where it's at, and I take care of it. So anyway, I believe it's going to work great. I thank you guys for riding along with me, and peace to you, and we'll talk to you in the next round. Bye-bye. Well, I just thought I was gone, but I just have this thing back in its where it lives, back on the bench. Just powered it back up. Absolutely flat. As far as I've not detected any vibration in there. Everything's good to go on that. I love this. But anyway, what I want to do is take that 6AW8 that come out of there, which is this tube here, put it on the tube tester, and I just see what happens. So it's already a 6AW8. We already know the filament voltage is 6.3. And by the way, my tube tester I got for $200 at I think it was in Shreveport. It was been at a flea market forever, and I've seen it, but I wasn't sure I wanted it because of these sockets here, and I didn't know a whole lot at the time, but I went ahead and bought it. I just kept going because nobody ever bought it, and I got that and a whole box of tubes for $200. And I know this ain't like the super duper Cadillac, but it ain't the low end either. It's a really good micro Muhal testing tube monitor. I call it micro Muhal. That's what we call it in trade scope. Anyway, let's set this up for 6A. Was it 6AW8, wasn't it? Yes, 6 Alpha Whiskey 8. So let's find 6AW8 on the roll. Oop, went right past it, I think. 6AW8. So it's 6.3. You look at the chart here. EV79863. EV79863. You're biased for 10. Right there. Okay, and then 88 for your English. Now, the mutual conductance is 5,000, so on mine, I don't set it for 88 exactly. I actually got 3 dots here. And this has to do, that dot has to do with these 3 scales, that 3,000, 6,000, and 15. So in case you didn't know, that dot right there corresponds, you'll see 3,000 written on there. That corresponds to this scale. 6,000 on this dot, that corresponds to that scale. And of course this dot, 15,000, to that scale. So you look on your chart, you say mutual conductance is 5,000. Okay, well, closest thing above that is 6,000, so that's where you set your English. But if you just wanted to use to replace good, then you would set it, the English, to 88, which in this case is 88. Anyway, let's see what else we got to do. So let's put the tube in. Alright, power up. Okay, let's hit the line adjustment. No line adjustment. Why don't I get a line adjustment? Like, well, no. There we go. I don't know what the deal was. This thing is probably, a lot of these switches showing that size one. Anyway, you push your line adjust, and you see that line test right there. You adjust your line adjust control, for that to be in the center, but it's right there. So the next thing we want to do is rotate the shorts button right here, and we look at this indicator right here, which is a neon bulb. So I'm going to turn you like this, and nothing there. So let's push the see how well it works. Actually, it works really good. It's a good tube as far as that goes. So what we're going to do now, something's up with it. So I'm going to put you on a tripod so I can have both ends. Let's see if we can, something wrong with this tube, we already know that. Something wrong in the hen house, as they say. I'm going to raise you up. There we go. So we can get all this in frame. See where it works good enough for us. Do a little telefolding. I'm going to put y'all over here. And get y'all as close to the top of this thing as possible. Sorry about that. Get this old camera to focus. Best I can do. So let's see. Now I got my hands free. Yeah, it's showing 55, about 5,600, and it's saying 55,000. And then I'm going to rotate the shorts again, and I'm just going to tap to get my little tester, and I'm going to rotate the short button again. You see the short indicator? Yeah. I don't know if it'll light up, but I'm just going to tap the tube. And rotate it. That's number one. Here's number two. Nothing yet. Nothing there. Back to GM. Now what I'm going to do is I'm just going to hold the GM in, tap on the tube. Oh, did you see that? I don't know if it was. I don't know if it's just something fluctuating, but something did flicker. Let's go to the next side. So it's EV2301. So EV2301-9. And we're going to do the same thing. We're going to do a test. Leak test. I'm sorry, short test. Okay, well, that's inconclusive. Let's see what kind of, ooh, that one there is not as strong. No, it only should be 2,500. Okay, well, let's do the let's do the gas test on this thing. So let's see here, trying to remember how to do this. It's been a long time. Yeah, let's see, we set this for 73, I think, and just for 100. I think we push this and we turn the English down until we get an indication of 100 mils. Then we push. That is gassy tube. There's your reference. You push this button. Look at there. Gassy tube. Let's check the other side real quick. Let's go back to 79863. So 79863, and then we'll set this again. Oh, that's a big difference. There's your reference. These tubes are a little bit gassy. So let's go back and set this for 1086. I want to bounce it one more time. It does fluctuate just a little bit when I tap on it, but that tube is gassy. And the triode section, there's a pentode section and a triode section in this tube. This tube's gassy. It's also extremely not usable. Well, alright, there you go. I think we're done now. Thank you guys. It's riding along, and y'all have a good day. Bye-bye.